Hello everyone, I am Hüseyin URTEKİN. My presentation is Nanotechnology and Carbons. I explain that nanotechnology and carbon nanostructures in this video. Biological structures have been an inspiration for the development of nanotechnology, considering the prevalence and indispensability of carbon in organic matter. All living things have a carbon-based life. It will be clearly seen how important the carbon atom is in terms of nanotechnology. What is the nanotechnology? Nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanoscience and nanotechnology are the study and application of extremely small things, and can be used across all the other science fields, such as chemistry, biology, physics, material science, and engineering. How it started? The ideas and concepts behind nanoscience and nanotechnology started with a talk entitled "There is Plenty of Room at the Bottom" by physicist Richard Feynman and American Physics Society meeting at the California Institute of Technology on December 29, 1959, long before the term nanotechnology was used. In his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. Over a decade later, in his exploration of ultra-precision machining, Professor Norio coined the term nanotechnology. It wasn't until 1971, with the development of the scanning tunneling microscope that could see individual atoms, that modern nanotechnology began. Carbon atom. Material composed of carbon atoms show very different physical and chemical properties according to the bonding geometry of carbon atoms. The reason that the carbon atom has such a feature is that there are 6 electrons. The fact that the first two of electrons of the carbon atom have no effect on bonding, as well as the large difference between the energies of the electrons enables carbon to different structures. No other elements with these properties make carbon unrivaled. Carbon bonding. Carbon atoms show 3 different bonds among themselves. These are expressed by the representation of Cp, Cp2, and Cp3, according to the mixture of electrons included in the bond. This representation also expresses the attachment geometry, as shown in figure. Carbon nanostructures. It's an interesting element in that it has solid structures infinite dimensions apart from crystal structures such as diamond and graphite. The bonding of carbon-based material in the form of Cp, Cp2, and Cp3 is also related to the size of these materials. Carbon is the only element in the periodic table that has isomers from 0 to 3 dimension in the existing elements. Since carbon one-dimensional and zero-dimensional structures are in nanometer range, these structures are called carbon nanostructures. Show that figure. Three-dimensional structures is diamond, two-dimensional structures is graphite, one-dimensional nanotubes, and dimensionless structure is nanoballs. The diamond structure shows Cp3 bonding and other structure Cp2 bonding. interesting structures consisting of only carbon atoms in nanometer size. These are generally cage-like structures that can be classified as balls, spheres, rods, and rings. Practical application areas of carbon nanostructures cover a wide area from electronics to medical materials. Nanostructures formed by carbon atoms are not limited to cage-like. For example, it's possible in a lumpy structure consisting of n carbon atoms. Carbon lumps have interesting structural properties. They take a certain shape according to the value of n. In that figure, the geometric shape of the carbon microplates from atoms number 2 to 10. If the atomic number is odd, one-dimensional, even number is two-dimensional ring. Carbon nanotubes. Several of the carbon atoms bonded together, they form ball-shaped cage structures. In 1974, Smalley and his friends melted and evaporated the graphite crystals with a laser. At the time, they realized that carbon atoms formed ball-shaped lattice structures in lumps and different size. These carbon balls contained up to 130 carbon atoms. About percent 75 of the balls formed during the evaporation of graphite consist of the balls with 60 atoms. Carbon nanotubes generally have a spherical lattice structure. The carbon atoms of this structure is due to their forming pentagonal and hexagonal surface. They can be the single wall with a structure similar to nested layers of the onion are located in a pair of groups are also available. Carbon nanotubes can be obtained both pure and additive. Carbon balls change the electronic and optical properties of the crystal surface on which they are placed. It's possible to make nanotransistors and even single electron transistors by using this feature of ball that can move by jumping between two surfaces. Application nanotubes. Nanotubes are used as optical limiters. These are coatings that are also used to protect material from excessive light. Polymers containing carbon balls exhibit photoconductivity. For this reason, carbon nanotubes are used as photodiodes, transistors, and also in solar cells. In addition, they act as a good protective against oxidation. It is strong enough to withstand a weight of 300 million times its own weight. It's not possible to find any other material in this robustness. A substance created from water-soluble carbon balls derivative has been found to limit the activities of the HIV virus. Carbon nanotubes are also used in hydrogen storage and high-energy batteries and as a friction-reducing agent between two separate materials. Carbon nanotubes. It was first experimentally noticed by Lishima in 1991 that carbon could form a tubular structure. Tube obtained by arc discharge evaporation method from graphite became hollow pipes as the graphite plate turns into cylindrical shape. Carbon nanotubes show semiconductor and metallic properties depending on their geometry. With no additives, the nanotube can also change the electronic properties by changing its geometric parameters. Tubes have an important place in electronic applications. They are very flexible and robust. The tensile force applied to break a bundle formed from small diameter tube is about 26 gigapascals. According to this, nanotube fibers are the most durable material against stretching. Application nanotubes. Carbon nanotubes are used in the production of magnetic and optical nanodevices as electronic materials. In addition, there are areas of memory elements, capacitors, transistors, diode logic circuit, and electronic switch making. In addition, carbon nanotubes have the feature of being the most solid material known. Carbon nanofibers have a very large surface area. The ratio between the mass and the area of the nanofibers is very large compared to normal materials. Thanks to this feature of carbon nanotube fibers, supercapacitors at the nanometer level. Hence, artificial muscles production will be possible. The large surface area, which also allows for hydrogen storage, makes carbon nanotube fibers a potential energy storage material. Carbon nanorods. The rods are made up of completely or partially filled tubular structures. The nested carbon tube. The distance between two tubes is generally greater than the distance bond between carbon atoms constituting the tube. In nested tubes, if the distance between the walls of the tubes is too small to allow carbon atoms to bond, the carbon atoms are connected. In other words, every carbon atom has four connected neighbors. The multi-walled tube structure formed in this case is called a rod. The flexibility of these structures is less than that of tubes. They also show different mechanical and electronic properties than single-walled tubes. Carbon nanoring. The two ends of the carbon tubes can be combined to form a ring toroid. These structures are considered theoretically for now. Many different ring models can be created with different inner and outer rings. Each different ring will show different properties. Carbon nanotubes advantages. In this page, we compare to carbon nanotubes to other materials. Carbon nanotubes, very small size, very low density, very high strength, and electricity and current and heat conductions. Applications area of nanotubes. Chemical and genetic probe mark DNA strand. Applications. A nanotube tripped atomic force microscope can trace the DNA strand to reveal chemical markers that determine which of several possible variables of a gene is in strand. Peeling technology is a nanoelectronic detection platform built on a carbon nanotube network. It includes a thin detection chip with one or two separate fasteners. Each of the fasteners is independently functional to resolve the specific target. Developed by the unique properties of carbon nanotubes and nanostructures registered production techniques. This device is a device with low energy consumption, small size and high sensitivity.